was remarkably, the anomaly, this was remarkably effective for describing kaons, pions, beta mesons, rho mesons, all of these different mesons, and their varying decays were very things. But there were a few things that did not work. One was pi and photons, which was why they used this. So that's where that came from. It's not a renormalizable Lagrangian. But that doesn't matter because the idea is it's a low energy effective Lagrangian. So when you go to high energies, the condensate dissolves and the actual thing. Oh, I'll write it over here. It's hard to see, sorry. Pi is defined as 1 over twice f pi times this condensate dotted into the common notation. Yeah. Well, it is. I mean, we did that. If you look at what the pions do, in some sense that's what we did whenever it was Monday of this week, I think, Tuesday, I forget. But, so it is. But the point is to generate this without worrying about those triangles. See, the quarks have all disappeared in this formulation. The mesons are all either pseudo-scalar fields or pseudo-vector fields or something like that. So the idea is, can you describe those interactions without going back down to the quark level? And the answer is, yeah, that term doesn't. That's the point. So you could. In fact, that's what people did. And so that's the connection. Does that make sense? Basically, yes, that's right. At the condensate level, that's correct. The idea is the quark terms just get wiped out entirely. The mesons have no idea they're made of quark. They behave according to that effective action with that other term. And this works very well, actually, to describe low energy meson physics. In fact, it works better, I think, than people thought it ought to when they constructed it. So the idea of that was to show you, it was to follow up on what that X gamma stuff does. It's used in generating, it can be used in generating effective actions, and partly, I guess, still is used if you're a person who believes that there is some structure to quarks or leptons or what have you, then similar ideas would be used, that an electron is the condensate of, I don't know, freons or regions or something. Those ideas were used there as well. To my knowledge, there is no positive evidence to support these kinds of substructure models, and people don't work on them anymore, or hardly anybody works on them anymore for that reason. And the favored substructure model is called that to be something like strings at this point. Yeah. Pardon me? I don't know why you use the word maybe gray. What do you mean? I mean... Yeah. In some sense, yeah. Well, for the abelian anomaly, it can't. There are theorems that show that it won't affect it. As I said, for the non-abelian anomaly, everybody thinks the same is true, but I don't know that there's a genuine, rock-solid proof of that. What happens if you add any other terms, you can add other terms to that thing. But remember, the condensate, there's a dimensionality to the condensate, which is expressed by that f pi squared, right? Q bar Q is not a unitless quantity. It has dimensions. That's what the function of the f pi is. So anything else you add, so the argument goes, would be that is a function of the condensate, would be dimensional, and it'll be suppressed by powers of a mass gradient scale. So you can do it, but unless that mass scale is very low energy, those other terms won't matter very much. But this one does matter, comparable to the other one. So this is something compared to that term that's the most important. My hypothesis here is simply it's the kinetic energy of the condensate. What's the simplest thing any physical structure can do? Well, it has energy of motion, right? Relative. So, all right. So what I think I'll spend the rest of the time on, I won't get through all this notion of an index theorem. So, just to give you some introduction to some of the mathematics behind this, there was this notion that E star of J5, remember, we saw in the path integral derivation was twice the sum of phi n dagger gamma 5 phi n, and that was 0 times infinity. The 5 gave a delta of x, but there was a trace of gamma 5. The 5 gave delta of x minus x, and the trace of gamma 5 gave 0. So when it was regulated, it gives us that, where f is equal to a half f nu dx nu wedge dx nu. That's what that f means. And upon integrating, what was pointed out a couple of days ago is this is equal to that. I'm tracing over, all these are solutions to d slash phi n is lambda n phi n. So I'm tracing over all the Diracology that is in here. But there is a completeness rule. Because of the trace, I can pull this around to the front and use the fact, I guess I'll have to write it down, that the sum well, it's implicitly over everything you can trace over the Dirac indices, the functions. Let me just write down what I was going to write down. Phi n of x, phi n, this is delta of x minus y. So because of this trace, I can pull this around to the front and use that. I'll get delta of x minus x, which is delta of 0, times, if I put in the Dirac indices, it's saying that's delta.